Okay, these are solutions to questions number 7 and 8 from pretest 2. And again, working with rational expressions. In question number 7 here, uh, multiplying two rational expressions. And so it's just as if it was one giant fraction. And so we're going to multiply by multiplying numerators, multiplying denominators. But first, we're going to factor. And that's sort of the key to this whole thing in working with rational expressions. You want to factor first. Um, General rule of thumb: never say never, never say always. But um, so factoring this numerator, we get x plus 3 times x plus 4. And the denominator on that left-hand side is x plus 2 times x plus 1. And likewise, on the right-hand side, we get x minus 4 and x minus 1. And factoring these things is the stuff of high school. In fact, elementary algebra, and so it ought to be pretty easy to perform these reverse FOILs. And if you're having trouble with it, let us know. We can do some other videos to sort of give you some of the bullet points to make you more successful. And finally, the x squared plus 6x plus 9 becomes x plus 3 times x plus 3. Now, as we multiply tops and multiply bottoms, you realize the only cancellation you have, numerator to denominator, are the x plus 3 and one of the x plus 3's in the denominator. They have to cancel numerator to denominator, and they have to cancel 1 for 1. So uh, we're left with an x plus 4 times an x minus 4 times an x minus 1 in the numerator. And in the denominator, you have an x plus 2 times an x plus 1 times an x plus 3. And so there's your final answer for question number 7. Not a lot going on there um, in terms of difficult algebra. Number 8, you got to see the structure. We're subtracting fractions, and as we've said before, add or subtract, you need a common denominator. And the common denominator in this case, pretty obvious. We have a quantity 2x minus 3, and we have a quantity 2x minus 3 squared. So as you compare those denominators to subtract, you sort of say, well, I'd like to multiply this by 2x minus 3. So it would be the same as the other denominator. Well, in order to do that, you must do the same thing to the numerator. So I multiply it by the identical 2x minus 3. The math idea is you're multiplying by 1, so you're not changing the value of the fraction. All right? Now, we did have somebody ask, can you square them both? Because then the 2x minus 3 would be squared. The answer to that is no, because if you square them both, then you're changing the value of the fraction, right? Just put a square on there, right? Well, it's not that simple, and then square the numerator. No, that would mean you're multiplying the top by 5 and the bottom by 2x minus 3, so that would be illegal. Instead, we're showing you here the tact you want to follow. Get the denominators the same by multiplying here by a 2x minus 3 so that you get your common denominator of 2x minus 3 squared. Do that same thing to the numerator. Perform your distributive property right here, and that gives you 10x minus 15. Combine the minus 15 and the minus 3 to get minus 18. There's your final answer. Right? Now, if you're looking for some extra canceling or something, like factoring out a 2, you could do that. Um, Factoring out a 2, you'd get 5x minus 9. It doesn't really lead you anywhere in that situation, not to a cancellation or anything like that. So either one of those would be acceptable as a final answer for me.